Hello. So we continue our lesson on the theory of the firm, and today we are in session 2 of the production function. So in this this video, we are going to look at the short-run production, and I believe that now you have some good understanding of the firm and how businesses are managed. In this video, I want us to look at the short run and specifically start to draw theories that will help us determine the equilibrium as we go on. Now, we distinguished in our previous video between the short run and the long run, and we said that the short run is a period short enough to allow for the not to allow for the adjustment of the firm's equipment and resources, while a long run is a period that allows the firm to adjust all of its inputs. Okay, so with that brief, then we can make an assumption. Let's assume that firms employ two inputs, capital and labor. Now, in the short run, capital is hard to change, so it is assumed to be fixed. If capital is fixed, it means that then the short-run production function takes the form Q equal to K FKL. Now, this bar you are seeing on top of K has been used to mean that capital is fixed. So, just a description of a definition of these variables. So Q here is the total output that the firm is producing by employing the factor capital and labor. Then F here is used to denote that we are dealing with a function. So it has no much implication, but it's just to tell you that you are dealing with a function. The K here is the amount of capital that the firm has employed in the production process. And this capital is assumed to be fixed, therefore we put a bar. And then the L here is the labor units that the firm is using in the production process. Now, since that capital is fixed, it means that if we start looking at the variable factors, then the production function Q will simply be the function of L. In other words, what we are saying then is that the change, to be specific, the change in output or expanding the output, if you want to increase more, the change in the output will be a function of L. So this means that for a production process, as we continue producing our output, we will have to be observing the units of labor that are being brought into the production process because capital is fixed. Therefore, the expansion of output will be dependent on the labor units that the firm employs. Let's turn our focus to the production total product function. So the total product is the total output of a particular good or service produced by a firm or firms or a group of, let's say a group of firms or the entire economy. Now, this means that whatever output has been produced, remember as we are going through this, we are assuming that capital is fixed. And the only factor that is varying is the labor. So with this then, the total output that we are producing it by adding labor or removing labor to and from the production process respectively. Let's look at the graphical illustration of the total product. So on the vertical axis, we put our total product, and then on the horizontal axis, we put the units of labor employed, being the only variable factor. Then from the origin, we can draw our production, total product function, TP. Now, you will notice that the curve, this shape of the curve is not by trial and error. It has an economic meaning, which I will take you through. So please pay attention and understand what this shape means when we are talking about discussing the theory of the firm. Now, let's have a point which we can call point A. Now at point A, you will notice that the total product curve is concave upwards all the way to point A, and then from point A, the total product curve changes the shape to being concave downwards. This means that point A is our point of inflection. It is a point at which the total product curve changes the curvature from being concave upwards to being concave downwards. It should be noted that even from observation, that the total product curve from O to point A, the total product curve is rising at an increasing rate. So this then is the part where now we need to understand what is really happening. It means that as you continue adding your labor units in this region, your output will be increasing at will be rising at an increasing rate. So we can note that if we extend the dots from point A, bringing it down, we can have, say, labor units L. So meaning that if the firm employs up to L1, in the region below from O to L to A, or let's say from O to L1, the firm will be increasing more to production for each unit brought in the production process. Moving on to another point, let's have a point B. Now, point B is the maximum of the total product curve. At point B, the total product curve, beyond point B, the total product curve will start to decline. Now, it should be noted that between this region here, because the curve was rising at an increasing rate and then starts to rise at a diminishing rate, it means from point A to point B, the total product curve is rising at a diminishing rate or at a decreasing rate. Meaning, as you add more units to your more units of labor to your production process, the total output will be increasing at a reduced rate. Now, I'll bring you to a table where you're going to understand what we mean when we say reducing rate or increasing rate and so on. Here, I want you to focus and understand the shape of the total product function. So from A to B, the total product curve is rising at a reducing rate or a diminishing rate. And if we extend the line from point B down, we can note that maybe at this point the firm is hiring L3 units of labor. And beyond point B, the total product curve is declining, meaning the shape becomes negative or the slope becomes negative. So just a recap that between point 0 to point A, the slope of the total product curve will be rising. And between point A to point B, the slope of the total product curve will be declining. And from point B downwards, this side, the slope of the total product curve will be negative. With this, let me take you to the average product. So the average product is simply the total output produced per unit of a resource employed. Now, as the firm keeps on adding or producing the output and adding more labor, the average product then becomes the measure of productivity of that input employed. That means for every output level, we divide the total output by the number of people employed to produce that output. Therefore, we are able to tell how productive is a worker brought into the production, or how productive are the workers in the production process by looking at how many units they are producing in relative terms. So computed, average product is simply the ratio of the total product to the labor units employed. If the firm has produced 10 units and for that production to take place, the firm hired 3 units of labor, then average product will be 10 divided by 3. In short, our average product is simply TP over L, where TP is total product and L is labor. So let's look at the table. So what we're seeing here is the first column is showing us the labor units employed, and the second column is giving us the total product produced for particular units employed. And then the average product here is what we are computing now as a ratio of the total product to the labor units employed. So now you will note that for the first line, where labor is 0 and total product is 0, it means we will be dividing 0 over 0, and that will be undefined, so we simply put a dash. So let's move to the second line, where we have our total product of 10 and our labor units employed of 1. And this, if we divide it, will give us our total product, our average product of 10. And this is a 10 we are seeing here. And if we go to the second one, we get total product of 25 divided by the labor units employed of 2, we get our average product of 12.5. If we move to the fourth line, where total product is 45 and labor units employed is 3, if we divide 45 divided by 3, we get our average product of 15. Therefore, average product is simply the output produced per unit of worker employed. Okay, so with that, then we can look at the average product curve. So I guess now you follow the routine here, so you will be able to calculate and verify that these are the average products for different levels of labor units employed and given the total product. Okay, so let's turn our focus to looking at the behavior of the graph for the average product. Okay, so on the vertical axis, we put average product. So this is supposed to be A. So this is average product. Okay, so we have average product on the vertical axis, and then we have labor units on the horizontal axis. So with this, we can have our curve. So this is our average product curve. So you will notice that the average product curve is rising from the origin, reach a maximum, and then begins to fall. So the maximum point, we can label it point E, and if we extend this down, we can have our L2. So let's say if the firm employs L2 units of labor, then the firm will be on the maximum part of the average product function. So it should be noted that the average product between point O to point E, the average product is rising. At point E, the average product is maximum. And beyond this, beyond this side, beyond the curve, you will notice that the average product is declining. Now let me take you back to the graph and see where this is. So you will notice that from this region all the way from 0 units of labor, which happens to be our point O, all the way up to the third unit of labor, average product will be increasing. Then just within from the third unit, if you add 1, average product will be maximum, so there will be no change. And if you go beyond the 4th unit of labor, average product will be declining. So this is the curve that we just plotted here. Now you will notice that the average product curve is not crossing the x-axis or the labor axis, because if you check the ratio, we are saying that average product is simply the total product divided by. Now, total product here will be a number. So as you move this side, what we are seeing is that you are increasing your labor units and therefore your production is increasing. It means you have a number here on the numerator, and whatever amount of labor you have in the denominator here, this ratio will not go back to 0. So it will keep on reducing and it will keep on moving asymptotically along the x or the labor axis, but it will never touch the labor axis. So this should be something that you should always remember as you are drawing your average product curve. Do not allow it cross the x-axis, because this ratio here, the best it can ever do is just go to 0. But because the number we have will be a huge number, maybe 0 point some number, some 0.0000, and so on. So meaning the only assumption you can make is that at least it can get closer, approach 0, but it will not be 0. Okay. So let's now move on and look at further analysis on the average product. A note. So it should be noted that after declining, average product does not go to 0, but approaches 0. Because as you keep increasing your denominator from the average product equation, the result will be declining but not become 0. And this is what I'm just from illustrating on the previous slide. Okay, let's now look at the marginal product. So the marginal product is the extra output or added product associated with adding a unit of a variable resource to the production process. Now, given this, then we are saying that when we are measuring the marginal product, we are measuring the additional output. If you are currently employing 3 units of labor, what will be the additional output which you will bring to the production process if you added another worker to make it 3? And that's what we are trying to measure here. So given this, then we can measure our marginal product as the change in the total product divided by the change in the labor units employed. With this, we can simply put it that our marginal product is delta TP divided by delta L. Now, I'm sure you recall that when we say change in total product, we mean total product 2 minus total product 1. So minus total product 1 divided by labor 2, so the second unit employed, minus the first unit in the line that you are computing that was employed. Okay, so this gives us the marginal product of labor. Okay, with that, let's look at the table and how we get those figures. So first column, we have our labor units. Second column, we have our total product. And in this column, we have the marginal product. Now, if 0 units of labor are employed, you will have undefined marginal product because you will be dividing 0 over 0. If you bring in 1 unit of labor into the production process, your total product will increase by 10, which means that at that level, you have your marginal product, which will be equal to TP. Let's write it like that. So you have your TP2 minus TP1 divided by L2 minus L1. So given this, then, for the first unit of labor employed, we see that our total product is 10, which means that our marginal product will be equal to 10 minus 0 divided by 1 minus 0. And if you check this, this will simply be 10 divided by 1, and the end results will simply be 10. So meaning for bringing in one additional unit of labor or the first unit of labor into the production process, total product increases to 10 and the marginal product increases by 10. For the second unit, so you'll notice that your total product grows to 25. So for the second unit of labor, it means that our total product, marginal product will be 25, which is our TP2, minus 10, which is our TP1, divided by 2, which is this units of labor employed, minus the 1, the previous number we have. And if we do this computation, we will have 15 here, divided by 1. And the end result will simply be the 15. And this is the 15 we are seeing here on the marginal product. For the third unit, it will be 45 minus 25 divided by 3 minus 2, and we'll have 20. For the fourth unit, it will be 60 minus 45 divided by 4 minus 3, and we will have 15. So we keep on moving with this until we finish to the end, and we'll notice that as we continue adding more units of labor into the production process, the marginal product will be rising, reach a maximum, and then starts to decline, reach 0, and then go to negative. So whereas the average product curve rises and starts to decline but never go to negative, the marginal product curve will rise, reach a maximum, decline, and then go all the way to the negative. I will take you through why this is the case. Okay, so now let's define some regions of returns to scale from this. So we notice that if we continue this computation, the part from 0 all the way to the third unit of labor, we have what we call the increasing marginal returns. So it is in this region where the marginal product moves from 0, goes all the way to the maximum part, and then starts to change the curvature. And then between the third unit and the 60th unit, we have what we call diminishing returns to scale. In this region, our marginal product is declining. It should be noted that it is in this region where the total product curve is rising at a diminishing rate. So with this then, here, total product is rising at an increasing rate because the marginal product is rising. And then at 20, marginal product is maximum, and then from here, marginal product starts to decline. And then if we go beyond this, from the 5th unit to all the way to, from the 60th unit all the way to the 8th unit, we have what we call negative marginal returns. Now, these marginal returns, so we have increasing marginal return, diminishing marginal return, and negative marginal return. So in this region, you will notice that total product will be maximum at the 60th unit. So beyond this 60th unit going down, total product will start declining, and therefore when total product is declining, marginal product will be going to the negative. And in this case, we have negative marginal returns, not returns to scale. It's marginal returns. So we'll come to returns to scale when we come to the long run. So the first part is increasing marginal returns, where total product is rising at an increasing rate. Then we have diminishing marginal returns, where total product is rising at a diminishing rate. And then we have negative marginal returns, where our total product is declining. Okay, so let's have a graph. So on the vertical axis we put marginal product, and on the horizontal axis we put units of labor. Drawing our curve, our marginal product curve, we'll notice that we have our point A, where our marginal product is maximum, and then corresponding to this we can have some units of labor employed being L1. So between O and L1, the marginal product curve is rising. At point A, marginal product is maximum. And as we move, we can note another point, which is point B, where marginal product is 0. So between point A and point B, marginal product is declining, but it is still positive, which means that in this region, total product is still rising, but it is rising at a diminishing rate. At point 0, we can label it with labor units employed as L3. And beyond point B, marginal product is declining or continues to decline, and this time around it becomes negative because you have added more inputs to your production, to the fixed inputs, and therefore the more labor you've added to the fixed inputs has caused people to get in each other's way. In the end, instead of working, they start chatting. So let me just take you through this region, this graph once again. So from point 0 to point O to point A, marginal product is rising. This is a period when the firm keeps on hiring people, and the people who are brought into the production process are adding more to the output produced. Because every worker has a machine to work with or has some resources to work with, and therefore they are adding more to the production process. In the region between A and B, this is the part where marginal product is declining, meaning that the additional workers that the firm will bring into the production process will now be adding less to the output produced. So if the first one added 3, you bring in the second one, added 4, which means the output goes to 7. You bring in the third one who adds maybe who adds 5, meaning your output goes all the way to 12. The fourth worker you may bring may not add more, may say 5. Maybe the fourth worker will bring in 3. The fifth worker maybe brings in 1. And then the 60th worker brings in 0. So you employ a worker, but output has not changed. It means marginal product is 0. It means beyond that worker, if you employ another worker, your output will now be declining, because at that point, all the workers you had employed are now fully efficient. They are all working. The next worker you will bring in will have nothing to do. Instead, he or she will be the worker who will be disturbing others. So he or she will be interested in chatting because the machine, there's no idle machine to use. All the machines are being used by others. Or this worker will just be seated somewhere, and then you'll notice that your production process will be low. So in deciding when to stop hiring, the firm should aim at point B, where the marginal product is 0. We will look at this in detail when we come to the stages of production. Okay, so let's now define the law of diminishing returns. So it states that as successive increments of a variable resource are added to a fixed resource, the marginal product of the variable resource will eventually decrease. That is, as you keep adding more and more labor to your capital, which is fixed, the additional output brought in by the additional workers you keep on adding will be declining the more you are bringing in labor. That is the law of diminishing returns. All right, so with this now, we can bring our marginal product and our average product curves together. So let's look at the average product, marginal product relationship. How are the two related? So on the vertical axis, we put average and marginal product. On the horizontal axis, we put the units of labor employed. Starting from the origin O, we can start by drawing our average product curve. So we have our average product curve here, which, remember, increases and then reach a maximum, starts to decline, but never goes to 0 or to the negatives. With this, we can also have our point, which is point E. That's a maximum or the peak of the average product curve. We can also bring in the amounts that are produced or employed, which is L2 units of labor. Okay, let's bring in our marginal product curve. So our marginal product curve will also start from the origin, reach a maximum, which we can call as our point A, and then from here starts to decline all the way to the negatives. Now, the relationship we are seeing here is that when average product is rising, when average product is rising, marginal product takes two forms. It rises and then starts to fall. In other words, when from O to the maximum point of the average product, marginal product will rise, reach a maximum, and then begin to fall. So it is the case that when marginal product is rising, average product is also rising. That is very true. When marginal product is falling, average product takes two forms. It will rise and then fall. So you will notice that at some point, so marginal product is falling starting from point A all the way moving downwards. You will notice that at this point average product is rising, reach a maximum and fall. So it should be noted then that marginal product meets the average product curve at the maximum of the average product. I'll say that again, so for those who are still trying to analyze what we are saying here. So the marginal product curve meet the average product curve at the maximum of the average product curve. In other words, this orange line meets the black line at the maximum of the black curve. So when marginal product is rising, average product is rising. When average product is rising, marginal product will rise and fall and start to fall. When average product is falling, marginal product is falling. But when marginal product is falling, average product will have a part which is rising and falling. Then we can add another point which we can call point B. So when we see point B here, this is a point where marginal product is 0. So you will notice that when marginal product is 0, our average product is declining. When marginal product is negative, our average product will be declining. So these are some of the relationships which you should always remember. And as we move to the next graph, where we'll be looking at the stages of production, you should try to think of this relationship and then make sense out of what we are going to present. Okay, so let's turn our focus to the stages of production. Now, these stages of production we are looking at here are the short-run stages of production. So let's begin first by looking at the relationship between the total product, average product, and the marginal product. So on the vertical axis, we put the total product, and on the horizontal axis, we put the units of labor employed. And then we have our total product curve, which changes curvature at some point A. And you notice that from this point A, we are saying a total product is rising at an increasing rate. And this point A is what we call the point of inflection. Now, corresponding to this, you can draw another graph at the bottom here, where on the vertical axis, you put the average product and the marginal product, while on the horizontal axis, you put the units of labor employed. Corresponding to point A, you can have a curve, which is the marginal product curve. So at point A, our marginal product curve is maximum, meaning that when the total product is rising at an increasing rate, marginal product will be rising. When the total product curve reaches a point where it changes curvature or changes the nature of movement or slope from rising at an increasing rate to starting to rise at a diminishing rate, which is the point of inflection, the marginal product is maximum. Now, beyond this, we can have the unit. So this is the L1. So I advise you to go back to the total product curve and the marginal product curve and see that where we had put our L1 and our point A, these are the points corresponding to the point of inflection or the maximum of the marginal product curve. So if we add, we put a line, let's call it a ray, from the origin all the way to the total product curve and make this line become tangent to the total product curve at point E. So when you draw a line which is passing in the middle of the vertical and the horizontal axis, this ray that you've drawn, if it at the point where it is touching the total product curve, so depending on how you've drawn the total product curve, but the point is at the point where this line that you've drawn is tangent to the total product curve. At that point, we have a corresponding graph, which is the average product. At that point, our average product is maximum. Now, you need to have a clear look here when you're drawing these graphs. So you need to draw them by stating first the point of inflection and draw your marginal product. Then you go on and find the point of tangency between a ray drawn from the origin all the way to the part where it's tangent to the total product curve. Extend that line and draw your average product to have a maximum point, and we have point E. So if you go to the average product curve in the previous slides we looked at, you will notice that we had point E. And on the total product curve, we also had point E. So this corresponds to the maximum of the average product curve. And then we have our L2. So you will notice that we had labeled this part as L2. In addition, we have our total product, which has now reached the maximum. Now this is one of the most interesting part, because at the maximum of the total product curve, our marginal product is 0. So our point B here, which corresponds to the maximum total product, our marginal product is 0. And when the marginal product is declining, total product is declining, you will notice that our our marginal product will be negative. So again, it should be noted here that when marginal product is rising, average product is rising. When average product is rising, marginal product will rise and will be falling on the other part. When marginal product is falling, average product will be rising at some part and will start to fall. But when average product is falling, marginal product will be falling. So that's the gap you see from point E going downwards. And then when marginal product is 0, average product will be falling. And at that point, our total product curve is maximum. When marginal product is negative, our average product curve is falling, and so is the total product curve. With this, then, we can define our stages of production. So let's have our first region. So the region from the origin O to L2, or from O to point E, which is the maximum of the average product curve, we have our stage 1 of production. Now, in this stage of production, we have a lot of fixed factors, which is capital, and less of the variable factor. It means that any input of labor or any units of labor that the firm will add to the production process will increase the production of the firm. In other words, the firm can also increase the production by reducing the amounts of the fixed factor. In this region then, the marginal product, whereas the marginal product of the variable factor increases and starts to decrease, the marginal product of the fixed factor, which is capital, is negative. And just to conclude on this in this stage is that a firm will never choose to produce in stage 1 because the variable factor are less than the fixed factor. And because the fixed factor has a negative marginal product, it will suffice, it will be well for the firm to continue hiring the labor units to increase production. So this is not the stage where the firm would decide to settle. The next stage of production we have is stage 2. Now stage 2 is a region from the maximum point of the average product to the point where marginal product is 0. In other words, just put simple, stages from stage 0 all the way to stage E, this part here, this is a region of diminishing returns and increasing returns, and then in this region we have the diminishing returns. So marginal product will rise, reach a maximum, starts to fall, output will still be increasing because you have every unit of labor you bring into production will be adding more. The ratio will be increasing. This is because the average product will be rising, meaning the output per worker will still be increasing, and therefore stage 1 is not a region to cut your production. In stage 2, we have our marginal product falling and our average product falling. Now, in this region, it is a region where output, total product, is still increasing at a diminishing rate, and every worker is now contributing less to the production process. You add in a worker, the output increases by a smaller output, and the ratio of output per worker is also becoming smaller. The firm, before we conclude on this one, let's look at stage 3. So stage 3 starts from where total product is maximum, or where marginal product is 0, all the way to the right of the maximum point of the TP. Now in this stage 3, our variable factor, now because we've hired too many units of labor, our variable factor has become more compared to our fixed factor. In other words, our variable factor has outnumbered the fixed factor. It is in this region where we have our negative marginal returns. It is in this region where workers who have nothing to do will end up disturbing others who are busy with the production process, and in the end, output starts to decline, or rather become negative. Instead of having more, you add in a worker, output declines. You add in a worker, if they were producing 10,000, you bring in a new worker, output reduces to 9,000. It means you are in stage 3 of production, and this is a stage of negative marginal returns. In stage 3, the marginal product of the variable factor is negative. Not in stage 1, the marginal product of the fixed factor was negative. This time around in stage 3, the marginal product of the variable factor is the one that is negative. So the firm will never decide to produce in stage 3 where the marginal product of the variable factor is negative. So the stage of production therefore is stage 2. The firms will decide to produce in stage 2 where both the average product and the marginal product are falling and they are both positive. At what part of stage 2, where exactly the firm would decide to produce depends on the cost of the variable factor. How much will it cost you to bring in the labor? Okay, so we wrap up that the firm will be producing in stage 2. So I will see you in the next video. If you have questions, please send your questions to muauelias@gmail.com. I will share with you the YouTube link that you will use to watch the video at your free time. Bye bye.